In under a long time since its send-off, the James Webb Space Telescope, JWST, has changed our comprehension of the universe. For researchers, the pictures it has caught open up additional opportunities in astronomy, while, until the end of us, they are absolutely dazzling to observe. Space experts overall are flabbergasted by an earth-shattering revelation. The JWST has caught far-off city-like lights 7 trillion miles away. This disclosure outperforms assumption, growing our infinite getting it and igniting hypotheses among researchers reading up the information for signs about these divine reference points. The disclosure recommends life past Earth, bringing up issues about extraterrestrial civilizations and the probability of life somewhere else. Join us as we disentangle how the JWST caught city lights billions of miles from our planet. Sent off on Christmas Day 2021, the JWST plans to be a further developed and strong imaging gadget than the Hubble Space Telescope. Its motivation is to get the most honed pictures of recently recognized objects, for example, planetary frameworks. Prior to plunging into the most recent discoveries, let's check the Hubble Space Telescope's part in space investigation. The spearheading Hubble Space Telescope, HST, sent off in 1990, still functional, has changed stargazing. A joint exertion among NASA and ESA, it satisfies a fantasy from the 1920s, made conceivable by innovative progressions. By the 1970s, the HST's principal mission was to convey high-resolution astronomical imagery, empowering definite investigation of heavenly items and extending our experiences into cosmic heavenly and planetary development. As a crane reflector telescope, the HST accomplishes the convergence of light from space objects utilizing mirrors. Its essential 2.4 meters, 7.8 feet, reflect, alongside a more modest optional mirror, reflects light to the central plane containing instruments for picture catching and information assortment. The Hubble is outfitted with different gadgets that help various perceptions of the universe. These incorporate cameras that catch pictures of space objects, spectrographs that split light into essential tones for investigation, and polarimeters that concentrate light polarization to identify properties of heavenly bodies. The Hubble's plan additionally incorporates space traveler adjusting capacities, taking into consideration fixes and instrument updates. The principal overhauling mission in 1993 revised an imperfection in the essential mirror by joining remedial optics. A sum of 5 overhauling missions have been led, with the final remaining one in 2009. The Hubble Space Telescope has perpetually changed our perspective on the universe, offering amazing imagery of heavenly items and making historic disclosures. These incorporate estimating the development pace of the universe, finding dark energy, and noticing the introduction of stars and worlds. Hubble's heritage reaches out past its disclosures, moving developments in cosmic advances and motivating new ages of researchers. The outcome of telescopes like the JWST expands on Hubble's inheritance, promising more profound bits of knowledge into the universe and propelling our insight into the universe's set of experiences. The JWST's profound field pictures plan to analyze the most old worlds, pushing the age of the universe to its earliest stages. By utilizing the nearby planet group as a device, the JWST portrays superb articles as their antiquated progenitors could have seen them. Space experts utilize light years, the distance light goes in 1 year, to determine these incomprehensible distances. The JWST's first show featured this idea by displaying a profound field picture sent off on July 11, 2022, by President Joseph Biden at the White House. This picture, like the Hubble's profound field pictures, focuses on a little fix of sky and identified around 3,000 new articles, generally far-off systems billions of light-years away. The JWST's profound field picture, like Hubble's, shows an apparently unexceptional bit of the night sky. However, within this little region close to the SMX 0723 cosmic system group, there is an abundance of information to be mined. This enormous group, roughly 4.6 billion light-years away, goes about as a characteristic amplifying glass because of its tremendous gravitational force. This peculiarity, known as gravitational lensing, permits space experts to dive more profound into the past, coming to the extent of 13.1 billion light-years. The emphasis on the obscure reaches out to the quest for life past Earth. The tremendous number of far-off universes disclosed by the JWST has touched off new logical request, especially with respect to a particular arrangement of Earth-sized planets that could hold hints to the presence of extraterrestrial life in our astronomical neighborhood. This pursuit addresses the firm catch-22, which questions the non-appearance of proof for cutting-edge extraterrestrial life regardless of the great likelihood of its presence. One star arrangement exceptionally compelling is TRAPPIST-1, found around 40 light-years away from Earth. This star framework, with 7 Earth-sized planets circling it, is crucial in the quest for tenable universes. NASA factors in different boundaries, for example, size, distance from the host star, and air composition to survey a planet's true capacity to support life. The JWST as of late accomplished an achievement by estimating the temperature of TRAPPIST-1b, the first identification of light produced by an exoplanet of its size and temperature range. This cutting-edge highlight showcases the telescope's awareness and potential to change how we might interpret rough planet climates. While the JWST investigates far-off universes, the Explorer missions continue to amaze researchers nearer to home. Sent off in 1977, Explorer 1 is presently experiencing a puzzling area at the edge of our nearby planet group. This unpredicted excursion adds another section to the incredible history of the Explorer missions. Initially planned to be short missions, the explorers have provided a huge amount of valuable information and expanded investigation for space science. These discoveries consistently help us to remember the ceaseless significance of curiosity and exploration. According to researchers, interstellar space begins where the sun's attractive field and the solar wind stop. Explorer 1 accomplished this achievement in 2012, while Explorer 2, a good ways off of 11 billion miles from Earth, entered this area in 2018. Strangely, new discoveries from Explorer 1 uncover astonishing peculiarities at this limit, known as the heliopause. These peculiarities incorporate eruptions of plasma and high-energy particles, testing past suspicions. This acknowledgement has driven specialists to presume that the heliopause, a long way from being a clear-cut limit, is a dynamic, ever-changing district affected by different elements from both inside our nearby planet group and the world. Past notwithstanding specialized hardships and the cruel realities of space, Explorer 2 continues to yield important logical information, thanks to inventive arrangements created by NASA designers. This is a continuous sign of humankind's persevering want to wander into the unexplored world, pushed by curiosity and the journey for information. In our planetary group, Venus has likewise become a subject of recharged interest after beforehand being excused as aloof due to its outrageous intensity. Ongoing perceptions by space experts have reignited logical interest in Venus. The disclosure of phosphine gas in Venus climate, a gas frequently related with natural cycles, has driven researchers to rethink the planet. Despite the fact that phosphine is delivered by organisms on Earth, researchers are cautious to avoid jumping to conclusions, considering other potential sources. The look for life on Venus delves into complex contemplations like synthetic responses, planetary development, and potential alternative natural processes. Venus' set of experiences likewise indicates a more calm past, potentially facilitating fluid water for billions of years. Drawing matches with Earth, this closeness brings up captivating issues about whether life once existed or could still exist in Venus' brutal climate. As opposed to the burning intensity of Venus, the cold surface of Jupiter's moon Europa is likewise a contender for holding life. Its subsurface sea, concealed underneath a thick layer of ice, raises the probability of life existing in outrageous conditions. The colossal distance of these background cosmic systems extends the light they emanate, moving it from the apparent range into the infrared reach. This shift permits the JWST, explicitly intended to identify infrared light, to notice these old universes with uncommon lucidity. By contrasting these perceptions with apparent light pictures from telescopes like Hubble, stargazers can piece together the fabulous story of cosmic development. This correlation offers a unique window into how universes have changed from their crude states billions of years prior into the superb structures we see today. One especially noteworthy part of the JWST's profound field picture is the speed at which it was acquired. Astoundingly, the telescope caught this information in only hours, displaying its excellent effectiveness in universe discovery. Besides, the amplifying force of gravitational lensing isn't restrictive to system groups. The JWST likewise caught a captivating picture of two interfacing cosmic systems known as VV11-191. When light from one system goes through the other, it gets mutilated, giving signs about the residue properties of the interceding world. This newfound information has the potential to disentangle novel insider facts about the fixings and development of universes. The span of the JWST stretches out past investigating far-off cosmic systems. A new secret on the official site recommends a potential locating of Aurora Borealis on a brown dwarf, a heavenly body that lies between stars and planets. This finding is amazing in light of the fact that brown dwarfs lack the internal fusion processes that power stars and produce auroras. Specialists are attempting to decide the exact wellspring of energy supporting these auroras, with some proposing a closely resembling component to Earth's auroras, where methane discharges cooperate with the brown dwarf's air. This examination could prompt a new comprehension of these puzzling, magnificent bodies. Another critical revelation by the JWST is the location of a very enormous dark opening. This monstrous dark opening, 40 million times greater than our Sun, is exceptionally dynamic and eating up its environmental factors. Found by Dr. Lucas Ferre and Ian at B College in Israel, the tremendousness of this dark opening proposes its huge effect on its host world's development. Luckily, this very monstrous dark opening lives a safe distance away, 12.9 billion light-years from our nearby planet group. Regardless of the tremendous distance, the JWST can peer through the huge enormous gap to uncover its forceful taking care of conduct. The ruddy shade distinguished by the telescope is probably brought about by a thick cloak of residue encompassing the dark opening, obstructing most light from getting away. This dusty cover likewise disguises the genuine size of the dark opening. However, when the JWST began communicating its underlying information, researchers were particularly amped up for three little items producing a blood-red sparkle. These items may be quasar-like elements, very gigantic dark openings at the focuses of universes effectively eating up matter. The curious appearance of these items, with their radiance concentrated inside a minuscule spot, raises inquiries regarding their nature. Gravitational lensing, a whiz peculiarity where monstrous items twist light, gave exact size gauges. Even when packed by the lensing impact, these dark openings make up a faltering 1% of their framework's aggregate mass, indicating their enormous size. Comparable behavior observed in other early universe very monstrous dark openings sheds light on their development and their relationship with their host worlds. Albeit numerous parts of this association remain covered in secret, the JWST discoveries offer important experiences. Separated from these momentous disclosures, the JWST has additionally caught other fascinating peculiarities. For example, a picture delivered by the European Space Agency, ESA, showed a little orange imprint, looking like a flipped question mark at the foundation of an image zeroed in on two youthful stars forming about 1,470 light-years away. Theories range from far-off systems to other unidentified factors. Further exploration is expected to decide the idea of this disclosure, which could open more secrets of the universe. The attention on the obscure reaches out to the quest for life past Earth. The presence of water, fundamental for life as far as we might be concerned, joined with energy sources from the Moon's geographically dynamic center, makes a convincing case for investigating Europa. Further missions, like the impending Europa Clipper, expect to examine the Moon's frosty hull, look for indications of something going on under the surface, and comprehend its likely tenability. The JWST's investigation of exoplanets offers new open doors to look for tenable universes. One such exoplanet, K218b, situated in the habitable zone of its star, has given promising indications of potential tenability. The identification of gases, for example methane and water vapor, in its environment raises captivating potential outcomes. While not conclusive proof of life, these gases show the presence of cycles that could support life. The variety of exoplanetary conditions, from gas monsters to rough universes, highlights the